Okay guys, welcome to this video, and again, sorry I'm getting it out kind of late to you. Hopefully it's helpful though. The goal here is to create a graph that shows the change in child poverty rate for different levels of spending on a child allowance. In the previous video and in the previous week, we had learned how to write a for loop that showed us the for different spendings on a child allowance, what did that do to the child poverty rate. But when it printed it originally, it printed it as a list. And we don't want it to print as a list. We want it to print as a data frame that we can use and eventually turn into a graph, so that we can display our findings in a way that's really readable to whoever we're sharing it with. So this is kind of where we ended on our code. I came in and I added a bunch of notes of things we need to add to make this a little bit more, to make this so we can add the graph at the end. So originally we only imported pandas library, but we need a couple others this time. We need NumPy. We need matplotlib.pyplot. This is the library that is the graphing library. So it'll have all the graphing functions and tools that we need, and we'll import that as PLT. And then one other kind of more niche library that we're going to need is matplotlib.ticker. We'll import that as mtick. What this library does is it allows us to add tickers to our numbers on our graph. So imagine you have an x-axis that you want to add dollar signs to. You can use this library to add dollar signs, or if you want to add percent symbols or whatever you want to add, that's what this library is for. So we've imported our additional libraries. The rest of this code, I guess let's just go through it so line by line so that it makes sense. Here we're importing our data, so we are still taking the data from Max's GitHub. We're importing these columns right here, which this is the original weight multiplied by 100. This is the SPM ID, which says which household each person is in. This is their poverty threshold, which says how much their post-tax and transfer resources need to be out of poverty. This is their SPM resources, is their post-tax and transfer income. So if this is bigger than this, then they are not poor. If their poverty threshold is more than their resources, then they are poor. And then lastly, we're going to import their age because we're doing a child allowance. This makes a copy of this data frame and just names it person. This takes all the columns of person and changes their case to lower. So it takes all these and makes them lowercase, so we don't have to worry about case sensitivity. This creates a new column, so that's a really important skill to just always remember. When we create a new column, we list the data frame and then what we want to call the new column, which is this divided by 100, because they multiply the original weight by 100 to get no decimals. We don't need that column anymore, so we delete it. Here we create a new column that says if person is a child or not, by saying if their age is less than 18, they're a child. Here we do the same thing for an adult. And then this process right here will create a column that says the total amount of children that someone has and the total amount of adults in their household. So I guess let's just explain that real quick. This is saying take the person data frame and group people by their SPM ID. Sum up the amount of children in their SPM ID, you can see child and sum up the amount of adults in their SPM ID group, which is their households, right? Then it takes, this line of code takes the result of this and creates a total children column and a total adults column. And this merges all of it back onto the person data frame. Here we calculate the total population of children in the US based on the data set. This should probably be named like child population. I just named it something kind of funky. you get about 74 million. This is the amount of adults. This is the amount of total people. So here we have the for loop, and I don't think I'll go into that, even though maybe I should, but I really want to get to the new content. And this note here says, our current for loop prints out a list, but a list cannot be used in a dictionary. So we will create an empty array to store our list in. So that's exactly what we'll do. We want to create an empty array that we can store the list in the for loop. So to create this empty array, I'm going to just name it, and I'm going to name it just so it's really obvious it's an array child poverty rate. And I'm just going to make it empty for now, right? There's nothing in it. And eventually what I'm going to do is at the end of this for loop, it calculates the child poverty rate. But again, this for loop is storing the data as in a list. And let's just talk about what the for loop does real quick. So for spending in levels from 0 to 500 billion at $50 billion intervals, what is the child poverty rate? And you could go through this if you want to pause and kind of make sense of this, but we kind of go over this in our last video, so I don't want to go too into that. So anyways, we end up with a child poverty rate in a list. But we need to... Oh, I guess, sorry, I was just reading my own note. First, I want to round it, so I'm going to do child PV rate equals child PV rate. I'm using the dot round function, right? So, and we're just going to round to 1 decimal place. So what this line is saying is take the child poverty rate, and if you printed this out, it would have a bunch of decimals. And it's saying use the round function to round it to just 1 decimal. So it looks nice in the graph. Now is here where I want to append the list to the array. So I'm going to use the append function. And I'm going to say take the empty array child poverty rate, and append it, so dot append, to the child PV rate. So it's saying take this empty array and append it onto here. So we have fixed our for loop, and at the end, our for loop has this array that is storing all the data of what's the child poverty rate at $50 billion of spending, then 100, then 150, then 200, then all the way up to 500 billion. So now that we have this empty array, I want to put it into a dictionary so that we can eventually convert it to a data frame and get a table that is easy to read. So it can be helpful to kind of understand the difference between a dictionary and a data frame. Dictionaries are one of Python's default data structures, which allow you to store a key value pair. They offer some built-in methods to manipulate your data, but data frames are gonna, when we use pandas, are gonna give us a lot more leeway in manipulating our data. So that's why once we create our dictionary, we're gonna convert it to a data frame. So I'm just going to name this dictionary, and that's bad form, but I just want you to really emphasize that this is a dictionary. And when I said key value pair, what I have right here is the key, which is really the name. So it's like the name that we're calling whatever value we're about to have next. So this key is going to go with this value. Well, the child poverty rate, what value do I want to go with that name or that key? I want the array that we just had. So I'm going to say the value that goes with that is the child PV rate. Good. And now when I'm ready to add the next item to my dictionary, I put a comma. And I guess I forgot to note the syntax between the key and the value is a colon. So next, I want the spending in billions, right? So spending billions. Now the value here I want is essentially 50 billion, then 100 billion, then 150, but it's in billions. So I really just want 50, then 100, then 150. So here I can use an NP arrange. And this is a function that works really similar to a for loop. You're going to start with where you want to begin. So I'm going to start at 0. I want to go all the way up to 500, but since I want to go to 500 and the second number is not inclusive, I'm going to go to 501, and I want to go at 50 in intervals of 50. So this is going to go from 0, 50, 100, 150, 200. I think you get it. So now I've created a dictionary, and if I print this dictionary, so I'm just going to print that for now, just so you can see what it looks like. Oh, I had to rerun everything. I created some new stuff without running it. So this is going to print this dictionary, and we'll see what it looks like. So here we have it. It printed the child poverty rates and the corresponding spending, but this is still not easy to read. The whole point of this is to make something that's easy to read for the reader. We can see the data, but now we want to display it in a usable way. So I'm going to take this dictionary and I'm going to convert it to a pandas data frame. A pandas data frame is the tables that we've been looking at the whole time. So I'm just going to call this, I'm going to call it dictionary_df for dictionary_data frame, just to really, so you see every step of the way what each thing is. And the way we convert something to a pandas data frame is really straightforward. We do pd for pandas dot data frame, and we put the thing in the parentheses that we want to convert to a data frame, which in this case is the dictionary. So we've taken the we're now making this called dictionary data frame, and I should just call it data frame, but okay, but now if I print this, then I should see a data frame. And there we have it. This is a lot easier to read. We have, at spending levels of 0, or the status quo, the child poverty rate in America is 13.6%. If we spent $50 billion on a child allowance, it's at 11.8%. And then you can see, and so on, if we spend $500 billion, it goes down to 3.3%. So we've created the table. And that is one way to display your data. I think a more common way to do it tends to be a graph. So we're going to use matplotlib to create a graph. And just before I go into this, I don't have all of this memorized. When I'm creating a graph in matplotlib, I'm looking things up. But you need to understand the basic structure so that you know what you can do. And so here you're going to see me, instead of typing everything out, I'm going to do a lot of copying and pasting so we can really get into the why instead of the what. So yeah, let's get to it. So I'm going to be going back and forth from the code that I already wrote. So I guess the first thing here is what's important is the documentation. I'm going to click on this link. So we're using matplotlib. So if you go into matplotlib.pyplot, it shows you all the functions that you can possibly use in that library. And there's a lot. And we're going to use, if you look at the code, we use plt.subplots. So if I go in here and I find subplots, okay. Now, if I look at this documentation, there's a lot of examples and stuff and whatnot, but this will help tell me what I can and cannot do with, and sorry, I'm stalling a little because, oh, here we go. Inside the subplots function is a lot of properties. And these properties tell me what I can't, like what I can all do. So like the title, I can add a title to my graph. The position, I can change the position of the B box, which contains the legend. The face color lets me change whatever the face of the graph is, so I'd have to experiment with that. And if you click in each one, it will tell, well, we'll get there. So anyways, so starting with the documentation is always just a good way to get a high-level overview of what you can do. And you don't need to read through all of this. I definitely haven't. But if you wanted to know how to find that, you would just search matplotlib documentation, probably. Yeah, and it's the first thing that comes up. So, okay, I forgot the .pyplot since we're using the .pyplot. And then here, you could click on any of this, but you can see the functions. No, that's .plot. Where's just, yeah, right here, pyplot, documentation. No, all right. Well, you can find it. I found it before. Oh, pyplot tutorial. Still doesn't work, but all right. And I don't want to start this video over. Okay, there's a list of functions in matplotlib.pyplot. Are they different? No. Okay, this is the same thing, just shown a little differently. So, I mean, you can find the documentation if you look at it. And I know this wasn't super clear, but I'm not going to start over. So, all right, so that's how we look at the documentation. So let's look at the first line of code now. Again, I'm just going to copy and paste so it's less typing and more explaining. So this first line is going to say, we're creating a graph. So you just, this is saying like we're going to create a figure, and that figure is going to be a graph. And we're going to call PLT. Remember, PLT just represents matplotlib.pyplot. So we're calling that library. And we're going to use the subplots function. So where was I in the subplots function? Here I'm in the subplots function, which means I can use any of these properties in the subplots function. I can add a Y label, Y ticks. I can change, the Y scale. I can do all these things inside of here. And one of those things is I can change the figure. And if you go into here, you'll see something called, the parameters for figure. And eventually you'll scroll down and you can see that you can change the figure size. So I call that figure size and I set the dimensions for my figure. So if I play this, I have an empty figure that is 20 by 10. But it has no data on it because I didn't tell it to put data on it. So our next step is we want to add data to this. So let's look at this function that I wrote here. I'm going to use the plot function inside the matplotlib library. So I'm saying take this graph. It already knows this graph was created in the PLT library, so I don't need to say that again. And we're going to use the .plot function, which I think I linked the documentation here. And again, this isn't a smooth process when I'm going over it, because it's not a smooth process when I'm doing it. Finding the documentation, all of that, none of it's smooth. And here are all the parameters and the properties for the plot function. So let's look at these in the code and then match them with the properties here. So the first thing I'm doing is I'm saying, okay, I'm in the dictionary data frame. On my x-axis, so whatever you choose first is going to go on the x, plot spending in billions. So I want to plot this on the x. And then comma, in the dictionary data frame, I want to, on the y, plot the child poverty rate. So now that tells it what to plot. But I also want to change a couple things to make it look a little better. So when I'm going through the the properties, one of the things is the marker. If I click on marker, you can see the markers. And here, if I call the marker property, I can put all of these different marks on my graph to emphasize the data. So I could put, a diamond. You can put any of these. Some of them are odd, but you can put any of these, and I'm just going to choose a circle. So to put a circle, you just put an O in parentheses. So that's what I did right here. The marker equals O. Well, I'm not going to go through and show you each and every one of these, but if you go into the property, which I need to go back now, you'll see marker size is an option, so I can change the size of the marker and all of these, and you can explore these on your own if you want. So I set the marker size to 12. The lines style, if you do double dash, it'll be a dash line. There's a bunch of different line styles. I want it to be solid. The line width I set to 4, the color I set to green, and I said I want this line, so this plot is talking about the line, I want this line to be called the child poverty rate. So now let's play this. And it looks a little better. We have a line that goes on our graph. It still doesn't look perfect. So let's think about some other things we might want to do. And I think next I decided that I wanted to add labels to this graph, right? I want to label the x-axis, the y-axis. Someone needs to be able to read this and understand what's going on. So that's pretty simple. And so I'm just going to copy and paste this code. So yeah, we're going to use, or say on this graph, which, you know, we call this graph, which might be intuitive, or I might be confusing you. You know, if you had a bunch of figures, you might call it figure 1, figure 2, etc. We just call it a graph for now. And we're using the setXLabel function this time. And yeah, so then you just say what you want to set it to. I want to set it to spending in billion, so it's just going to print this string. And it has some default settings, but I'm going to change one of the settings. Anything you can change on text, now you can change to this text. So any text property is in play here. So I'm going to change the font size for the X and the Y. And for the title, I'm going to change the font size, make it to 25, a little bit bigger. And the font weight, which makes it bold. And then you can also change the color. So, all right, what if we made it blue for this time? So there. Yeah, the blue doesn't look very good. So now we have axes labeled, and this is starting to make a little bit more sense. We have a title. Someone could look at this and kind of understand what's going on, but you know, you want to present something good. This is your research. You might want to make it look a little nicer. So one thing you might do to make it a little more intuitive is create grid lines. And if you want to see the documentation for the grid lines, again, because this all comes from the documentation, and you can easily find the grid lines on your own, or you know, if you search matplotlib.grid, this would come up. So you can find these on your own. I know I linked them. But you can do all the same things to the grid. You can do some similar things. You can make it dashed, and I think that's one of the property I use. You can put markers on your grid. Yeah, I don't know what all these do, but you know, if you want to do something, maybe you can find out. So I'm going to copy and paste that grid code. Well, plt.grid, and then what did I choose? So here we decided to change the line style and the line width. So the line style I'm doing is double dashes this time, and the line width I'm setting to 1. If we look at the documentation, line style, if you click in here and then see, you can see the examples here, solid or dashed or dash dot. I wanted the dashed, so I did the double dash. So now let's play it. Okay, cool. We have grid lines. It's looking even better now. What else do I want to do? Okay, so now I want to change, and this didn't really have to be done for this graph, but I just wanted to show you because this is one of the more important things. I want to change the ticks. And actually, it is pretty important for this graph. You know, we have ticks we have markers on the 50s, but the grid lines are only on the hundreds. So I want to add 50, 152, 53, 54, 50, so I can change the ticks. And that's what I did here. I'm calling the plt.yticks function to change the y ticks first. And I want it to go, and again, this is kind of like the for loop. I'm using the np_arrange function. I want it to start at 0. When I say 13, that means it's really only going to 12, and I want it to go by increments of 2. And you can also change the size of the ticks. These are kind of small, so I'm changing them to size 20. I'm doing the same thing for the x ticks. So now if we play this, okay, our ticks look a little bigger. It's coming together a little more. Our graph's really coming together. All right. What do I do next? Okay, so this next part, yeah, let's copy and paste and then talk about it. This is something, I'm going to be honest, I had to ask on Stack Overflow. Stack Overflow is just a place where you can ask people coding questions. But now I think I understand it pretty well. So let me try to explain. So here I'm creating a variable y ticks. And I'm saying y ticks are equal to, on the graph, so this graph is called graph, the y-axis major ticks. The major ticks are the ones we actually see. The minor ticks you don't see. There is a 3, you just don't see it. So it's saying the y ticks are equal to basically all of these. And what I want to do here is I don't like this 0. I want to get rid of that 0. I think it looks weird. So I'm saying the y ticks take the 0th number in the index and take the set visibility property or function and say set the visibility to false. Now I'm writing 0 here not because I want to take away the number 0, but because I want to take the 0th number in the index. Remember, indexes in Python start at 0. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So say I wanted to take away the 10 for some reason, you wouldn't. But it's the 5th number in my index. So if I say take away the 5th number in the index and I play it, look, the 10 is gone. But that's not what I want. I want the 0 to be gone, which is the first number, the 0th number. And now that 0 is gone, it looks a little better. Okay, the next part is the trickiest, and I don't know if I'll really dive too much into it. This was also something I had to look up online. I didn't find it in the documentation, but you can say that PLT has a function GCA, which stands for get current axes. And what this is, let me explain what we're doing here. I want percents on these numbers, and I want $signs on these. So that's why we called the mtick library in the first place. So what this is going to do is say set major, y-axis set major, so take the major ticks, and use the formatter, and call the mtick library. They have a property %formatter, so you just have to call that, and set the decimals. I don't want any zeros. I think the default is 2. So if you don't set decimals to 0, so like if I take this out, if I take this line of code out, I believe it'll show decimals. Oh, maybe you had to set the amount of decimals. But if I set decimals to 2, there'll be 2 decimals. I don't really think that's necessary. So I'm just going to set decimals to 0. And there we go. We have the percents on the side here. You'll notice it also added the $signs. And that was this line of code real quick here, which is basically saying create a variable formatter that calls the mtick library and formats the string. Put a $sign in front, and this %sign is just kind of standing in for an X random number. And this 0.0 means basically 0 decimals. So it's saying put a $sign in front of the number with 0 decimals. And now this code right here is saying take the major X ticks from the graph and call the formatter function and use the format, which we just called formatter here. So you can see how that turned out, right? And it's okay if you don't understand this, especially with something like matplotlib. Make a really good graph that you're proud of once, and then steal from yourself. That's expedites the process and gets the job done. Okay, so I think the second to last thing I wanted to do here is I wanted to take away the frame. So again, and I linked all the documentation for all of this when I'll share you on this code. Feel free to look into it and see what other cool things you can do. Don't get caught up only doing the steps you see in this video. Go through the documentation and see what's possible. Or just, I don't know, if you think of something like, oh, I really want to What would make this graph different? I really want to label an important point, right? I want it to say like at $250 of spending, it's at 7%. I want to label this point. Look up how do I label a point on a graph and figure out how to do it. So anyways, I want to take away the frame. I don't like this black box on the outside. Don't think it looks very good. So I'm saying figure GCA, which remember stands for get current axes, set frame on, so frame on to false. So if I play this, the frame is gone, and I think it looks a little better. You might disagree, but here was the documentation for that. If you wanted to see, remember I'm in the GCA function of the matplotlib.pyplot library. And you can see all the parameters here, and one of them is frame on, which is a bool, which just means it's true or false. So I set it to false, which means obviously off. Okay, last thing, you can see the finished graph has a legend, but my current graph doesn't have a legend. So plt.legend, again, is a function inside the matplotlib.pyplot library. I'm calling that function. bbox to anchor is kind of how I can move the legend box customarily. So if you can think about it, at the very edge is 0 on the x, and the very other edge is 1. So this 0.95, I'm basically telling it to go 95% of the way over. Same thing with the y, it goes from 0 to 1. I'm saying basically go 95% of the way up. And then this prop is just how I set the size of the text. So if I play this, I have a finished graph. There's a legend. So it looks pretty good. I think it displays the data pretty well. This is a static graph, which is easy to share on blogs and things like Medium. In this code, I have a pre-code where you can just practice making your own, which I highly recommend doing if you did not get to participate in last week's class. Yeah, and always feel free to reach out with any questions. I think that pretty much covers it, and that's the end of the video.